This video is for class 8 chemistry, and this is the continuation video for the indicators and metal activity series. We are still in page number 80. You can refer your book and go to that table. If the video is clear, then you can watch the table in the video only. So this is the activity series here. If we check this out, this is the activity series here, right, from top to bottom. Potassium being the most reactive, whereas the platinum being the least. So this metal reactivity series in this table is grouped, right? In this table is grouped first group, second group, third group, and the fourth group. And it becomes easier if we study the properties of a metal in a group. That's why we are studying something called periodic table. So we are learning the reaction of these elements with oxygen, water, and acid. So how do they react with oxygen, water, and acid? If they react, and whether it reacts or not. Okay, let us go one by one. Potassium, sodium, and calcium, they are highly reactive, so they can react with almost everything. So potassium, sodium, and calcium reacts with oxygen at ordinary temperature. If we keep potassium, sodium on the table, starts reacting and forms potassium oxide and sodium oxide and calcium oxide. Then we go to reaction with water. Potassium, sodium, and calcium can react with cold water, right? Even it can catch fire. This potassium and sodium can catch fire when you put them in cold water. You can watch the videos if you want to. You will find in the YouTube, okay, many videos. It's not necessary, but if you watch those videos, it might generate some interest in you. The reaction with acids, potassium, sodium, calcium, all three of them react with acids explosively, right, vigorously. Here they have written less vigorously. Here the meaning of less vigorously means less than potassium and sodium. It reacts vigorously compared to this metals here, right? Next group, magnesium, aluminium, zinc, iron. Okay, reaction with oxygen. All of them react with oxygen, right? They form oxides. After reacting with oxygen, they form oxides like magnesium oxide, aluminium oxide, zinc oxide, iron oxide. But aluminium also reacts at ordinary temperature. Magnesium also can react at ordinary temperature, but for zinc and iron, I think we need to heat them, right? The reaction with water, they all react with water, right? Magnesium reacts with hot water and steam, whereas aluminium, zinc, and iron can only react with steam, right, to form their respective oxides. Here also they form oxides, right? Next, reaction with acids. All four of them reacts with acid to give hydrogen, but they react moderately, right? Moderately means they react less violently than the above three elements. The next group we have lead, copper, and mercury. They are slow kind of elements, right? We have lead oxides, copper oxides, and mercury oxide on very high heating. The high heating here means around 350 to 400 degrees Celsius. Then reaction with water, they do not react with water, right? They do not react with hot water or steam also. Reaction with acids, lead reacts with concentrated hydrochloric acid to give hydrogen. Copper and mercury do not react with acids, dilute acids, right? They react with concentrated acids, right, to form a special compound. We have to study them in class 10. Then we have silver, gold, and platinum. Reaction with oxygen, they don't react. They are the slowest of the lot, right? Reaction with water, no reaction, okay? And reaction with acids, they do not react with dilute acids. They only can react with concentrated acids because of the property of concentrated acid, not them. Okay, then we can go to the next page number 81. We have come to page number 81. Some more displacement reactions are as follows. Like if we check this out, zinc is reacting with copper sulfate. Zinc is more reactive than copper. Yeah, sorry, I just overlapped it. Zinc is much more reactive than copper. Zinc is reactive than copper, this line, because zinc is above that activity series. That's why zinc is kept above copper in the activity series. So zinc reacts with copper sulfate to give zinc sulfate and copper. So zinc can displace copper, it can take the copper out of copper sulfate and take the sulfate with it, right, because it is much more reactive than copper. Next we have magnesium and iron sulfate. Since magnesium is above the activity series, so magnesium can displace iron. Magnesium can displace iron. So that's what happens. Magnesium takes the place of iron and becomes magnesium sulfate, and iron is liberated, right, alone. The next one is zinc and sulfuric acid. Zinc can react with sulfuric acid to give zinc sulfate and hydrogen. Hydrogen is below zinc in the activity series, which suggests that hydrogen is less reactive than zinc, and zinc can displace hydrogen. A more reactive element can displace a less reactive element. That's what displacement reaction is all about. Zinc is more reactive than hydrogen. So non-metals also show sometimes displacement reactions, right? If we take the example potassium iodide, potassium iodide reacts with chlorine. Chlorine being much more reactive than iodine, it takes the place of iodine and becomes potassium chloride, and iodine is liberated here alone. Okay. Next we have types of chemical reactions on the basis of energy change. So this topic I would like to discuss in the new video because it will be too long. This is quite long. Exothermic, endothermic, etc. we have to explain. So this much for today. We shall meet in the next video. Thank you so much.